Alright, so this will be an intro into the Calculus 3 playlist. This whole video series will just be about stuff you see in Calculus 3 or multivariable calc, same thing. And we're going to be going over things like, planes, finding equations of planes, spherical coordinates, multiple integration, partial derivatives, all that stuff you would typically encounter in a Calc 3 class. And then at the end, I'm going to go more in depth into vector calculus, which I'll touch in my video series. But vector calculus has a lot of interesting things that I'm not going to get into right away, because you don't necessarily see it in Calc 3 right away. You kind of see really what you can do with vector calculus kind of afterwards. But that's kind of beside the point. So really this video will just be an introduction into what I'm going to be talking about for the entire playlist, which will be about, I think like 40-ish videos. I'm not really sure how many, but I kind of guesstimate it'll take me about 40. Anyway, so really one of the most important things to note in Calc 3, it's really three-dimensional space. You have an x, so you have a y, and you have a z axis. And I've only drawn the positive x, y, and z, and I'll show you later how to do. Actually, I'll just do it now. Really, to do a full XYZ coordinate system, all you really do is you draw a line, and you kind of just draw x just like that. And then you have your x down here, your y down here, and your z over there. Kind of like what you have over here. You kind of just draw this little, draw the outermost arrows first as your positive x, positive y, and then you have your z. And then from there you can just, fill it in. Negative z, negative y, negative z, and then negative x. And that's how you draw the entire full coordinate system. I'm not going to be using this coordinate system too often, because it's not really needed to do a lot of problems. You really can just focus on the positive orientation. And so really, it's kind of just what you've been doing with x and y coordinates, but now we're adding a third component. And because we're doing that, it's 3D, and so you can have all kinds of surfaces. Here I've drawn like some kind of sheet, and then I've drawn it above the XY plane. And here you have like a projection. You can kind of think of it as a shadow, really, which essentially what I'm doing here is, if the sheet can be moved down to here, I'm just trying to illustrate that the z-axis, we kind of have a height now, not just we're not just going left and right. We can now go up and down, and that will be important to doing really all the problems in Calc 3, especially when we get into integration. But really, it's a lot of the ideas from Calculus 1 and 2 kind of easily extend over to Calculus 3. A lot of the ideas are kind of the same. We're just kind of adding a few extra twists to it. So really, we're going to be working with 3 coordinate systems. The ones you're probably familiar with from Calculus 1 and 2 is the Cartesian or rectangular ones. We have a point, and we have an x coordinate, a y coordinate. Now we have a z coordinate. So those are called Cartesian, and they're also called rectangular. But now that what we're doing Calc 3, is kind of time we call them properly. They're called Cartesian coordinates. And then we're also going to be working in cylindrical coordinates. Just kind of drew a cylinder down here, kind of obvious. And then we'll also be working in spherical coordinates. Now, cylindrical coordinates, they're a little bit different. Instead of having x, y, and z, we have a radius, and then we have a z, which is the height, and then we have the angle theta, which is essentially important, because the top and the bottom are circles. So really, the whole thing is kind of like a collection of circles if you think about it, kind of just extended upward. And basically, in order to specify a point in cylindrical coordinates, we need a r, a z, and a theta. And we're going to get into how to convert between the 3 of these in later videos. And then for spherical coordinates, we have a rho, we have theta, and we have phi. And again, I'll be getting more into detail about that later. But basically, these are the 3 primary coordinate systems we're going to be using. There's also a curvilinear coordinate system, but that's not really used in Calc 3 very much. So we're just going to kind of focus on these 3 coordinate systems. And so basically, to really illustrate the point that a lot of the ideas from Calc 1 and 2 extend over to Calc 3, here, I've drawn the familiar, a definite integral, from a to b of f of x dx. If you remember, it's just the limit as n goes to infinity from 1 to n of f of x sub I star delta x. And really, if you remember that, all we're really doing is we're essentially we have our little, graph right here, and then we essentially we have an area from a to b, and we kind of just divide it into a bunch of rectangles, and essentially, the more rectangles you get, the more accurate your area is. So that's pretty much what this is, what the Riemann sum is saying, if you guys need a review from that. And so what you can do is, instead of just having one variable here, you can actually have 2. So for the double integral, which I'll of course revisit later, but basically you have a function f of x y dA, which is the area, and then its limit as n goes to infinity of the double Riemann sum of f of x sub I star, y sub I star, delta A, or delta area. So really you can kind of see that this translates over to the double integral pretty nicely. And so if you understand this, this will make a lot of sense. And the triple integral is also very, very similar, and I'll be getting more into that much later. Double integrals and triple integrals are kind of more towards the end of the Calculus 3, you know, the way it's usually taught, it's usually towards the end. But basically, that's kind of an intro. So really, we just have three primary coordinate systems. You know, we're pretty much going in 3 dimensions always. All of these are in 3 dimensions, and we're going to be doing all different kinds of things, all different neat tricks that you can't do in Calculus 1 and 2. You can do in Calculus 3. So really, it's really useful to study this because it's really, I think, the first math where you can kind of see there are a lot of very practical applications. In Calculus 1 and 2, they're kind of like not really that useful. I mean, it's kind of useful, but not as useful as this. And so that pretty much is the intro to the Calculus 3 playlist. The next one I'll be talking about introduction of vectors. So hope you guys enjoy, and I'll see you in the next video.